What's up, everybody, and welcome to another hopefully very helpful and inspiring tutorial. I'm Kevin Adams, and today we'll be building from the ground up a super cool cross-sectional render setup in C4D using the amazing Redshift Render Engine. Let's get into it. First, we'll start with a quick overview on how I've set this up. After the overview, we'll start from the beginning and I'll show you step by step how I built this. So what we're looking at here is the entire setup of this cross-sectional effect, all contained in one material, and that can work on any object. This is actually a really simple setup. It has two main components: a ramp that is connected to the opacity channel of the material, controlling the cross-section opacity, and another ramp that is connected to the color channel, controlling the awesome edge glow that you see coming from the incandescent node. Grab a drink and let's jump into building this. First, we'll create a simple shape to set up the cross-section material with, and then we can bring in some other objects to demonstrate. You can use any 3D model you prefer. So create a cube or any basic shape that you would like. Now create a new Redshift standard material. Name it something like cross-section. Next, apply the material to the object. And now let's open up the material. We're going to load in a color ramp node and then duplicate that node. We'll set the duplicate off to the side for now. Now plug this ramp node into the opacity channel by dragging it out under geometry, selecting opacity. And now we'll open up the RPR window to see what's going on. And you'll see there's some weird opacity happening, and it's definitely not what we want yet. So select the ramp node and click on the black color knot position 1 and set this to 50%. Do the same for the white knot position 2, 50%. And that's all we have to do for this node. Now we're going to set up the vertex attribute node, so we're able to control the cross-section opacity using a linear field. Now load a vertex attribute node in and connect it to the alt input channel of the ramp node under general input, alt input. Next, in your objects list, right-click on your object and under the other tags, choose vertex map tag. Select the tag and under the basic tab, name it cross section. Now open up your material, select the vertex attribute node, and click and drag the vertex map tag over and drop it into the attribute name field. What this does is it connects the tag to the node so that they're seeing each other. To have control over the opacity though, we have to create a field which will be the controller for wiping on and off the cross-section opacity. To do this, make sure the tag is selected and go under the Fields tab. Add a linear field by clicking and holding down this field button, then releasing on linear field. Now we see that the linear field is controlling the cross-section opacity. Now we can change the orientation of the field so it slices the object at different fixed angles. Or we can simply select the field and with the rotate tool, rotate the field at any angle we want to slice and dice however we want. And if you wanted a softer fall off on the opacity instead of a hard edge, you can simply change the value of the ramp from 50-50 to any difference you want to get more of a distance in between the fall off. As you can see here, it's more of a gradient than a hard line. And I'm going to set it back to 50-50 for now. So if you wanted to cross-section another object, for example, this sphere, simply drop the material on it, control-click and drag the vertex map tag to copy it to the new object, and boom. You're now controlling a cross-section of both objects with one linear field. But wait, what about the cool edge glow effect? I haven't forgot. All you need to do is open up your material, select the other ramp node that we set aside, click the black square, change it to 51%. Now click the white square and change it to 49%. Change interpolation to linear. Now from the out color of the vertex attribute node, plug into the alt input of this ramp node. Next, we'll add a color layer node and an incandescent node. Plug the color layer node into the color channel of the material, and then plug the incandescent node into the color layer under layer 1 color. Next, plug the ramp into the color layer under layer 1 mask. Set the incandescent intensity multiplier to something like 20. Now, to get the glow and lens effect, we'll have to create a Redshift camera. Go to Redshift, Camera, Standard. Now toggle into your camera view, and with the camera selected, go to the Lens Effects tab and turn on Override to activate the bloom, flare, and streak effects. Now reset the IPR window, and you should see the lens effects in action. You can dial in the lens effects to a desired result like so. That's looking pretty good. You can also change the width of the glow edge by selecting the ramp connected to the color channel and playing with the ramp values for more of a fall off. And then to change the color of the glow, select the incandescent node and click the color swatch to select a desired color. And you'll have to refresh the IPR window to update the color change. So we just went through how to set up cross-sectional renders on basic objects without diffuse or color maps. Now we're going to look at how this cross-section material will work with a diffuse or a color map in the material. We'll use the skull, which has a color map plugged in already. We'll open up our project that has our pre-built cross-sectional material, copy it, and paste this material into our skull project. Now open up the cross-section material and copy all the nodes that are plugged into the standard material. Then open up the skull material and paste them in here. Now disconnect the diffuse color node of the skull map from the standard material and plug it into the base color layer of the color layer node. Now we're going to arrange the nodes so everything is clean. Now plug the color layer node into the color channel of the standard material and plug the ramp back into the opacity channel. Now let's open up the IPR window so we can see what's about to go down. So there's no change, and this is normal because we have to add the vertex map tag and link it to the vertex attribute node for this all to work. So let's add a vertex map tag. Select your vertex attribute node. Drop the tag into the attribute name field like we did before, and it disappears, which means everything is working because we have to add a field in order to reveal the skull for this all to work. So click your vertex map tag and check the use fields box. Delete the freeze layer and add a linear field. Now we can see that the scale of the edge illumination has increased due to dropping this setup onto a different model. Sometimes it's going to vary depending on which model you're using and the size of the model scale. So all you have to do to adjust this is select the linear field and slide the length slider back until you get a desired result. Something like that. Now you can slice and dice however you want just by moving the field through it. Pretty cool. I hope you guys found this tutorial helpful. If you did, be sure to like and subscribe so you can catch the next one coming up. Until then, thanks for the support and see you next time.